so much into details about our other architecture, for example, how we use Cassandra and stuff. I'll try to focus mostly on Python. So first, I'm going to tell who I am, and I'm going to give you a short intro into the Cloudkick, so actually get a bit knowledge and background what the Cloudkick actually is. Then we'll take a look at the whole architecture, which services we use, how we use them, and so on. Later on, we're going to check why we choose Python and how we use it with Cloudkick. This means how we use it in our web stack, how we use it with our web app, and how we use Django. We'll also have a look how we use Twisted and other libraries and Python in our network services. Also going to look how we do service communication, RDC, and logging. Also going to peek at testing and also at how we use Python in some other places. So first, who I am, I'm Tomaž Muraus. I work for Cloudkick, or basically acquiring more rack space. I mostly work on backend stuff, so different backend services, mostly written in Python. I also did some work in C and Lua and so on, but I mostly work on Python stuff. Also out there are multiple Python libraries and Django apps, which you can find on GitHub. Also a big open source support and lover. And I'm also a Apache Cloud committer. So first, what is Cloudkick? Cloudkick is a product, a software as a service, which allows you to manage servers. There could be physical servers in a data center or a cloud service using a single dashboard. This means you can manage all your servers and monitor them using a single website, single dashboard. You can also set up different alert thresholds and monitors. For example, you can set up battery check, CPU check, memory check, and so on. Then we install the agent on your server, and then agent sends data back to us. We then process it, insert it in Cassandra, save it so we can later on drop really graphs, so we can also alert you. You can also use different tools to annotate your graphs. For example, if you you upgrade your application, deploy a version of the application, you can use our command line tool called CPL. And for example, you can specify a message. Message could be upgraded to version 5.0. You will automatically see this version all over your graphs, which means you can correlate different events. For example, you deploy a new version, and then you see that CPU usage maybe dropped or maybe went up, then you can think it's probably related to the recent deployment and so on. This is just a few features. Here are some screenshots. This is our dashboard. Basically, each bar represents a server. Each slice basically represents a server. It's hard to see because the projector is up anyway. Here's a single server view, as you can see. You see like all the graphs related to the servers, recent anomalies, so basically recent alerts, recent problems, and also diagnostic, which is like the top. You can see this live wait server. We basically use comment and we push live data, which means this refreshes, I mean this automatically updates. This is also the recent anomalies page, where you can see recent alerts, recent problems, and so on. Here's our but basically it's a nice little JavaScript and HTML5 web app where you can view your servers in 3D. Sorry, the picture quality is bad, but basically we have two axes. One is CPU, one is ping, and one is memory. Basically, a dot or a circle represents a server, and basically server moves in space depending on the current ping, CPU usage, and memory. And also, if you click on a server, you can get all the details, recent alerts, current CPU usage, and so on. And dot also pings thread with something, for example, if a threshold has been triggered, an alert has been sent. Basically, this is all live use comment for this, which means stuff updates instantly. So first, I'm going to talk a bit about our architecture. Our whole architecture is actually quite complex, but in general, we use MySQL as our primary relational data store. But for storing all the time series data, all the metrics, we use Cassandra. We're also one of really big Cassandra users, and like I said, we have a lot of data in Cassandra, and we store that there. And we also use Solr. For example, if Solr is basically indexing search server, we use Solr to store different documents about your server, and then you can find them using our dashboard. And for example, you see the web app part. For the web app, we use Django framework. And there is also a RabbitMQ. We use RabbitMQ as a queue server, basically for our event framework, about which I'll talk later. There is a big box which represents services. Basically, our architecture is mainly composed of different network services. We have like 40 or so many different services that each of the services does some simple tasks, and they're also horizontally scalable and so on. I'll talk more about that later. There on the right side at the bottom, you see Cassandra. This is a place where all the time series data goes, and there is also a place for stream services and Scribe. I'll talk about Scribe later. It's basically a tool which has been open sourced by Facebook and allows you to aggregate your logs and stuff. But I'll talk about how we use it. We actually don't use it for aggregating logs, we also use it for some other stuff. On the left, you can see a yellow circle which represents your server. Basically, for monitoring the work, of course, you need to install some kind of agent in your server. Basically, you install our agent in your server. Our agent is written in C, and it also supports Lua script, which is kind of interesting. Basically, our agent, the core is written in C, but it has Lua interpreter built in. We decided to do this because, of course, with C you have memory management and so on, and it's hard to write like a CPU check or memory check or disk check. That's why we decided to embed Lua interpreter, and you can write your CPU, basically all the CPU check and all the code for communicating with our servers is written in Lua, which makes it a lot easier and more cleaner and simpler to write. And basically, once your agent is installed on your server, it opens a persistent TCP connection to our server and pushes different matrix with it. You see the highlight, you see that's our so-called service which communicates the agent, or actually agent communicates with the server. Also on the picture you can see Orbited. Orbited is a server within Python which uses comment, and it's used for real-time communication. So why Python? I mean, I don't need to talk about that here. So yeah, Python and Cloudkick. Like I said, our architecture, we basically use many different languages. We also use C, C++, Java, and so on. But our primary development language and most of our services are written in Python. We use it in our web stack, so it's Django, and many other libraries. We also use it for our network services, where we most use Twisted. Also talk a bit how we use Twisted, some problems we encounter, and so on. And we also use it, which is great for like random small scripts like cron jobs and so on. It's actually a really nice thing. With Python, you can like write real serious apps, web apps, network apps, whatever. But you can also use it to like automate some small tasks. So for web application, like I said, we use Django for our web app. We've been using it since the beginning. So far, we've been pretty pleased with it. Our web app is actually, it's not like a typical CMS and so on, which means we needed to modify quite a lot of stuff. It wasn't so straightforward, but we're still pretty satisfied with it because so far we haven't had any security problems yet. So which means we haven't had any XSS down, which means Django team is taking good care of the security. And we also use Salt, which is a Python library for performing schema migrations and data migrations. So we basically, like I said, use MySQL as our relation data store, and for adding columns, we use Salt. It's basically, if you use some kind of migration tools, they do support like removing columns or editing them, but of course in MySQL, this means if you use MyListen, that if for example, if you execute others table, the whole table would be locked for it, which is obviously not acceptable in production. So you usually just end up adding new columns. We also use for our API, we use Piston. Piston is a library which has been open sourced by Bitbucket. It's meant to be used to create or write the REST APIs. We use it for that, but we also modified a lot of it in Python. For example, we changed the default JSON serializer because I think the default version used Django JSON serializer, which should, I think, fall back to simple JSON, but for some reason didn't. And we changed that to directly use simple JSON, and it works a lot faster now. We also modified it to support OAuth 2. OAuth 2 is basically the authentication mechanism, but OAuth 1 is pretty complex. You need to create a signature and so on. It's not so straightforward from a developer perspective, and OAuth 2 addresses this. That's why also our API recently added support for it. Like I previously said, we are also a big Cassandra user. At the time we started using it, it was like what we started in 2009. At the time we started using it, there weren't like many good or like well-tested libraries available. That's the reason why we decided to basically build our library and our app for our apps. I'm not sure if you know how Cassandra works or how it previously basically uses Thrift. Thrift is a binary protocol for exchanging and serializing data. Cassandra uses Thrift for communication, so our library also uses Thrift to communicate with Cassandra. Thrift is kind of nice, but I'll also talk more about Thrift later. And yeah, we use Solr for indexing all the node data and allow you to search for all your servers and so on. And we use Solr for that. And for communicating with Solr, we use Solr PI, is a Python library. We also made some modifications to it because by default it uses XML. Basically, it uses XML to send documents to the server, and by default it expects XML from Solr server, and we basically modified it a bit to return JSON, because Solr supports JSON as well, but the library doesn't. Actually, the library, there's a reason why library doesn't support JSON. JSON, there is no way to natively store dates. That's the reason why the author decided not to support JSON, but it's not a problem for us because we never use date field. We never use date field in a way that we'll need to convert it in a native datetime object in Python. But if we need to do that, we could do it. We could just save date as a JSON and do some post-processing after receiving document, but so far we haven't needed to do that. Yeah, for profiling, we have multiple servers. We have a staging server, which uses the same database as production server, which means we usually use staging server for debugging different performance problems. For that, we use profiling middleware for Django, which is actually really, really simple. It uses Python C profile. It shows a list. Here's a screenshot that basically shows a list of all the execute functions and so on and queries, but it's basically very useful with this little page script where you can do a lot. You see which queries, how many queries executed and so on, and then you can basically optimize it. I mean, ORMs are great, but in many cases sadly we need to use different tags. For example, in a lot of places we call list on a Django query set to evaluate the whole query set early before we pass it to some other function, because the query set basically gets only evaluated once and we have better performance. In some places, sadly, we also use some raw queries because this was needed to have a good performance. For logging, we use Django Sentry, which is basically a simple app which allows you to basically provide a nice REST API where you can post your log messages, and then you can see all the messages aggregated. Oh, I had a screenshot, but anyway. It has a nice view when you can see all the servers. For example, if you post messages to multiple servers, you can filter messages per service and so on. So now I'm going to talk a bit about Twisted. We are also a pretty big users of Twisted. We use it for like 95% of our backend network services. Twisted is great. I mean, it's old. It's been there for like more than 10 years. It's well tested, and there's a pretty good support. I mean, the bug tracker is pretty active, and it supports almost any protocol you can think of. It's kind of like when even if you work for Twisted with even if you work with Twisted for multiple years, like every time you still discover something new, it has just so many features. But there is one problem. I mean, writing Twisted code, good Twisted code and performant Twisted code actually isn't that easy, and you need to be careful how you use it. So basically, for all of you who don't know, Twisted is a framework which allows you to write different, usually networking apps in a synchronous model, which means the synchronous model means that all the application code runs inside a single thread. Basically, there is no multiple processes, which makes some stuff like synchronization and things like that easy. Basically, you don't need to have logs, mutex, and so on. But also, you need to be careful because if you have some operation which runs for too long, you block the whole reactor thread, and which means your application basically pauses while this operation runs. So far, do you have any questions? So this slide also included some random tips which are good to know when you work with Twisted. For example, one thing we have a lot of fun with, or we had, is the on-cut exceptions. For some reason, when there is an on-cut exception Twisted after a long period of time, it starts to leak memory. This is also if you have a, which of course you in production usually do, you have a debugging turned off, right? So it's not a debugging problem, but for some reason, after Twisted services run for a long time, and if you don't handle all the exceptions, it starts to leak memory. Second thing is that you need to be careful to defer to threads. Like I said, Twisted is asynchronous, which means that everything by default runs in a single thread, but usually not all the libraries you use are asynchronous. For example, we use libcloud a lot to talk with different cloud providers, and libcloud is blocking, it's not asynchronous. This means that if we just execute some libcloud function inside the reactor thread, it will block and it wouldn't work. Well, I mean, it would work, but everything else that we pause while the libcloud functionality is running. That's the time when you use Twisted threads, defer to thread function. This is basically a function which runs some blocking code inside the worker thread. Basically, Twisted maintains a thread pool. I think by default it's 10 threads or so. When you call this function, it just instructs some free worker thread to execute it. The problem is that you need to be careful how you use defer to threads. If you use defer to threads too many times, your application performance will start to suffer. We learned this recently usually when some new person starts to work on Twisted code, they put the defer to thread around every blocking operations. This usually results in a very bad performance. And in cases like this, when you have a lot of blocking code, you usually need to group those blocking code and move it inside that function and defer just this single function and thread instead of deferring all the function. And then you'll probably have good performance. But also you need to keep in mind that in this case, we don't use threads for performance reasons. We use them for not blocking the reactor, and of course threads in Python are not like, because of the global interpreter, not like real threads. You don't usually use it because of the performance reasons. There's also a pretty useful thing in Twisted we use, which is email lock observer. Email lock observer is basically just a simple lock observer which sends all the exceptions of all the errors to your email. It's very simple, but it usually helps. Yeah, there is another thing we use for recording different application-specific or service-specific matching during the service lifetime. We use a really simple stats library which allows you to record different metrics during the application runtime, and then you can view these metrics by going to this library HTTP interface. Basically, it integrates with Twisted, which means that it runs an Twisted HTTP server which you can visit, and then you can view all the metrics which you have logged basically in a JSON format. Here's a really simple API. Library has 10 or so methods, but it's very useful. For example, counter is just a simple counter. We usually use it just to count the number of operations. The one which is pretty useful is average. This operation, basically you usually use it when you want to record how long some operation takes. For example, inside your tree-set you have some code. It's probably some kind of database or something like that. And before running the service and after running this function, you record the time and then you use average to save it. You use some key, for example, this is usually your function name. And then this function automatically calculates the minimum value, maximum value, and average. This is usually useful, especially if you wrap your database calls with this and you can see if there are like some possible performance problems. There's also a count calls decorator, which basically just counts how many times a function was called. So it is like a really simple example, so you can see how you could, for example, use the counter API. In this case, I use increase operations. Increase operations is a method which tracks how many times some operation has been executed. Basically, when you call it in an increase operation method, it will increase this operation total count and pending count. Basically, until you don't call the increase operation, the operation will be in the pending mode, which means it's executing. And usually, when the operation finishes, we call it, like you can see in the example at the end, the decrease operation, and this will basically decrease this operation or this the pending counter. This is usually useful, especially because, like I said, these metrics are available live through the HTTP interface, because you can see how many of each operations you have waiting, and you can like see if some operations are usually taking a long time to execute. Here is also another example. In this example, I use the average function, which I talked about previously. In this case, you see I just record the time and add it, and later on I can see the message. So that's the actual JSON which you get when you hit the web interface. You also have some other fields, like for example state and status. That's because this JSON is Cloudkick compatible, which means we are a monitoring service and you can post JSON in this form to us. It kind of makes sense for our stats library to export metrics in this format, so you can integrate it with Cloudkick and automatically search alerts and so on. So we have service communications. Like I said, we have a lot of different services and they need to communicate somehow. For this, we use event framework, scribe, and drift in different ways. Event framework is basically, in our case, used a lot, and it basically it's based on the message passing design pattern or paradigm. The event framework supports multiple policies, supports fan-out, round-robin, and scope round-robin. Fan-out means when you have some topic, for example, server started is a topic, and you have multiple subscribers, like three subscribers subscribe to this topic, all the subscribers will receive it. Fan-out is a second policy. Fan-out usually allows you to create a load balancing algorithm. For example, you have 3 subscribers, all of them subscribe to the same topic. Here, as you see, that's first, that's fan-out. So you can see up there we have a publisher that's usually a web app in our case, or it's also a Django service. This publisher publishes 4 messages, as you can see, and we have a broker, which is in our case the actual server or service, which implements all the routing, sending of the messages and so on. In our case, this is RabbitMQ, and down there you see subscribers. Basically, in this case, in the fan-out policy, each subscriber receives all the messages, which is this second example. You can see the round-robin policy. With the round-robin policy, in this example, we also send 4 events, but in this case, the events are balanced round-robin, which means the subscriber 1 receives message 1, subscriber 2, 3, and 1 again receives message 4. This is very useful with our services in general, with different services, because you can implement basically a simple load balancing algorithm. And the last policy which our events framework supports is a scope robin. It's very similar to the round robin. The difference is that with scope round robin you provide a tag when you register. For example, you want to register and listen for all the events with the topic server booted, but you can provide a tag. We usually, for this tag, we usually use a service name, and this policy allows us to load balance some event with the same service. For example, we have multiple instances on the same service, and we would like to load balance between them to share the load. And that's the base where we use this policy. That's an example of subscribe. As you can see, we basically we have a ready hook. It's a function which is executed when the whole event framework is initialized, which means when the library connects to the Rabbit and so on. Basically, in the ready hook, you register. See this case registered for test 1 and test 2. For first one, we register with penalty policy, and with second one, we register with round-robin policy. And here is an example of how we publish event. This, for example, in this case, it's a sync, so it means it's used for twisted code. But instead of a sync out there, you could use sync, and you could use it from the Django code. As you can see, you simply the event is the actual message payload. So in this case, we send the node update event, and in this case, the actual payload is node name update, which means some server has changed the name. That's why the message contains the old name and the new name. You basically specify the event, the payload, and then you just publish it. And then our framework and RabbitMQ handles the actual message dispatching. We also use the event framework a lot. Basically, our web app and a lot of our actions in our web application are blocking. Of course, we have two options. We could execute this application inside the web app, this means inside the Django view code, or we could, of course, run it inside the service, which makes a lot more sense because it doesn't block and user doesn't need to wait. So that's basically one of the ways we use this event framework in Django code. For example, when a user adds a new monitor on the website, this means we need to add it to all the servers which manage the query and so on. Instead of doing this inline, we just send the event, dispatch an event from the web app, and then we have a special service which handles just the applying of the monitors to servers. So we have testing. I don't think many people love testing or like it, but you need to do it, and we also do it, but we basically have 3 different styles of tests, or our test suite is composed of 3 different styles of tests. First style or type of test is a simple functional test. Those tests just test just simple functions and simple functionality. For that, we use a Django framework, test framework, which is based on unit test and unit test itself in some cases. Second type of test we have is integration test or twisted service test. In this test, we test our twisted services code. This means this code is a sync. That's also the reason why we use twisted trial test framework. For both of the test types, for Django tests and for twisted tests, we've written a custom test runner. By default, Django tests and twisted tests run inside a single process, which means if you have multiple cores, most likely your server is not utilized well and it does run slower. That's also the reason why we've written a custom test runner, and this custom test runner runs tests inside of multiple processes. Basically, it creates a process pool and it dispatches tests to different processes, and then multiple tests run in parallel, and this turned out that now our Django tests and services tests basically are around 50% faster, which is great because testing is already painful, and if you can speed up, that's good. Anyone have any questions so far?
Don't be shy.
I have a question about this extra custom module that you have programmed for Yeah, but do you have intentions of putting open source somewhere, or is that private tool?
So you want the event framework or?
No, the test runner.
The test runner, yeah, I have a post on my blog and I have a guest, so it's kind of open source. It's just not like back inside a single Git repo and just inside a guest. But yeah, I can share a link with you later on.
Okay, thank you.
Anyone else? Okay, I also want to talk a bit about how we use, like I previously said, we use Stripe. Stripe is a Facebook tool, which Facebook is open source. It's primarily used for aggregating a lot. Primary selling points of Stripe are that it's fast, you can handle a lot of messages, and that's also one of the reasons we use it. For a lot of the stuff we use event framework, but it turned out that actually RabbitMQ doesn't perform so well when you have a lot of messages. That's one of the reasons that in some places, instead of using RabbitMQ, we use Stripe. For example, the service I showed up at the beginning, which shows your service in a 3D space, and you can view stuff live. We use Stripe for that. Basically, agents push data to us, and we send it to Stripe, and Stripe has a concept of different backends, which is basically, backend is usually a file or could be something else. In our case, one of the backends is a Cassandra backend. This backend basically just saves all the time series inside our Cassandra cluster, and you can also send multiple, basically you can configure multiple backends, and the other backend sends this data to the user browser using the, basically we have a service which listens on a Stripe stream, and Stripe also sends the same data to this service, and this service then figures out all the state changes. For example, if something is changed, if you wish to trigger some alert and so on, and we also publish these state changes using event framework to a special queue, which is created when a user connects in a website. And we basically, that's how we handle real-time stuff. So yeah, other places. We also use Python in many other places. First one is deployment. For deployment, we mostly use Fabric. The Fabric is good, it works well if you have simple deployment process and you don't have that many servers, but it gets complicated. For example, in cases like ours where we have a lot of servers and our deployment flow is a bit more complicated, this means Fabric is not the best fit for this, and we're also working on some tools to improving that, but it's a topic for a different talk. And for continuous integration, we use BuildBot. BuildBot is similar to like Jenkins, or actually, yeah, Jenkins was previously called Hudson. It's a continuous integration service. But BuildBot is similar, but it's written in Python, which means it's a lot more fun to work with it than with Jenkins, which is written in Java. And we also use Python in a lot of other places. That's it. Let's answer questions.
Question about Cloudkick services. Is it possible to use Cloudkick services over OpenStack instances, private instances?
Yeah, sure. We have an agent which you install on the server. So yeah, you can use it. We also have a special build system which handles building all the best packages for different distributions and stuff. And basically, agent works on most of the popular Linux distributions and Windows as well. It should work there. Anyone else?
Questions? I have a question. So, where we can find documentation about services and what we can find on the OpenStack?
You can find all the documentation or our website on the wiki, and the website is cloudkick.com. You can find everything there.
Other questions? Okay. Thank you.